Okay, so what I've done is I've actually pulled a systematic review and a meta-analysis for us to kind of go over. I'm going to walk you through how I go what I do when I'm looking at a research article and hopefully what you're doing. Now, the first thing you want to do is anytime you pull any sort of article, just make sure that the abstract is what you're looking at. So right here, the abstract, does it cover sort of the content, the results, etc. that you want? Now, don't just rely on the abstract, okay? Make sure that you read the entire article. If you're going to be a true consumer of research, you don't want to get stuck in just reading abstracts, because when you actually get into the results section, you might find some problems with it. Now, this is going to make a little bit more sense later on in this unit when we talk about the PRISMA guidelines and actually what should go into a systematic review or a meta-analysis in terms of the different steps and aspects and content. But for now, I just want to kind of go over exactly how you read it. So we've gone through the abstract. We sort of have an idea what the study's about. Now, for our purposes, we don't really know and or care what the FTO gene variant is. We're looking just more at the general overall view of it, okay? So don't get bogged down in the science. Now, as I'm going through the abstract, the first thing I notice right now is that they're talking about pooled odds ratios. You can see that highlighted right here. Now, if you remember one of the readings from a previous unit, we talked about basic statistics for clinicians, and you're going to notice that relative risk, absolute risk reduction, odds ratio is there. So you might want to take a second and go back and review this article on odds ratio. It might make the research article we're about to go over a little bit easier. So we're kind of noticing that right away in the method section. And we know it's a systematic review meta-analysis because luckily it says it right in the title. And that's great. We don't have to go searching for it too much. So first thing is the introduction. Whenever you read an article, the introduction should give you a fairly quick, brief, and apparent topic what this article is about. You don't want to have to go searching high and far for what this article is about. So it should say right in the introduction exactly what the researchers are trying to find and what they're looking for. It really hooks the reader and makes sure that this is actually the article you want to go through. Now, all good systematic reviews are going to have some sort of literature insert strategy. And when you do the PRISMA guidelines coming up later on, you'll see exactly, they really do a good job of spelling this out. Make sure as you're reading it, you go through the search strategy and you see how they actually found all of the articles that they're searching for. Now remember, this is an exploratory type of a design, all right? So they're not necessarily going in there with a preconceived hypothesis or a preconceived notion of what they hope to find. They're just exploring whatever they find, they find. So keep that in mind. They're just looking for all the search criteria, all the articles that they could find, and they kind of pull it together and they run a statistical analysis on it. Now, here's a statistical analysis, obviously in the results section. Don't skip the results, okay? The results are very, very important. So a lot of people like to kind of skip the methods and results and go right to discussion. Don't. This is actually a lot of what tells you if the study is a good study, a bad study, high quality, or poor quality. So as we continue through, what you're going to find right here is this is the flow chart for article selection. Now, when you do the PRISMA guidelines, they are very specific of what they want to see, but you can see when you're reading your systematic review, they should have this either in graphical form or narrative form, what they started with, and how they sort of had attrition through their articles and eventually what they ended up with. So they ended up, the final meta-analysis, so the final statistical analysis had 23 studies, all right? And they took those 23 studies, they ran the meta-analysis statistical test on it, and this is what they came up with in this paper. So again, as we come through here, we're going to see sorry, it's sideways. I know it might be hard for you guys to read, but you can see here are the studies, and this table is actually going to be very good, and it should have all the basic type of information. The author, the year, this has country and ethnicity because it's obviously an international topic, but it should also go through the statistical analysis that they ran, what their value was, and any other sort of pertinent information. So again, don't skip these tables. Go through them with a fine-tooth comb and make sure that the years are accurate, that the authors are accurate. There might be a couple very well-known authors that you know of, and make sure they're listed here in these systematic reviews. If you know of a really great paper that you know an author and the systematic review doesn't include that, that should be a red flag. Like, why didn't they put that author in their review? That's a red flag to me. So as you go through this, you should be able to figure that out. Now, here's the big one. Now, when you go back through and you read this Interpreting and Understanding Meta-Analysis Graphs, a practical guide, which I included on the webpage, it does a really nice job of kind of showing you how to read this graph. Now, this graph is called the forest plot, okay? And as you go through, I'm just going to teach you some of the basic things you're going to look for, kind of quick and dirty when you're looking at a forest plot. I'm not going to go through all the statistical steps you need to actually calculate it, but when you see one of these things, I want to make sure you don't get overwhelmed with it, just how to read it, apply it, and go with it. Now, the first thing you want to remember that this is an odds ratio, okay? That's what they're looking at. Now, an odds ratio is basically taking one thing and compare it to another, all right? Now, anytime you have a study, you want to find a difference, okay? You want the null hypothesis to be incorrect, meaning that there is a difference between groups. If there's not a difference between the groups, then what's the point of doing the study? So when you're talking about an odds ratio, the key number is the number 1. You can see that right here. Because if you have a value on the numerator and a value on the denominator, and they are the same, when you divide them, you get 1. And that means because they're the same, there's no difference. And there's no difference, that means the study wasn't worth doing. So anytime you look at a forest plot, find your what's called the line of effect. In this case, because it's an odds ratio, it's the number 1. And what you're looking for when you look at all these different studies are if the whiskers, which are these horizontal lines, cross the line of no effect. If it crosses the line, not a good study, okay? For one, there is at least one data point that shows no difference. And that's what we want. We want a difference between the two groups. So this study right here, this study here, this study here, they all cross the line. Therefore, we don't like these studies, okay? They're crossing the line. And when you go to the confidence intervals, you can see that is mentioned there. So the confidence interval, 0.98 to 1.36. The value 1 is included in between those two, okay? But if you look at this one, that is completely to the right of the number 1. You can see the confidence interval, the numerical value 1 is not included in it, all right? So you have the graphical representation. You can also double check it using your confidence interval numbers. But the bottom line is you look for the line of no effect, and you want everything to be on the side that has an effect, okay? As you go through a forest plot, as this article also shows you, it's going to have a whole bunch of different symbols, okay? The squares are where this point in this particular study, that's where the effect was for that particular study, okay? So you can see they're going to be varied because different studies have different effects. Here are your whisker plots, and this is your confidence interval. Again, if you remember all the way back from the previous articles, a wider confidence interval is bad, so you want small whiskers. So you want nice, tiny whiskers, not big whiskers like this guy. You want small little whiskers, all right? And the bigger the box size, the bigger the percentage of weight that this particular study had in the whole meta-analysis, okay? So if you look at this guy right here, huge confidence interval, which you can see noted there, and a little bitty box. So its percent weight is only 1.74. But look at this guy, okay? Small confidence interval, big box. Small confidence interval, huge percent weight compared to the one below it, all right? So again, when you're looking at these forest plots, you want to see the whiskers, the line of effect, and how big each of the individual studies are in terms of the percent weight of the overall. And the last one are the diamonds. You'll see a diamond here, diamond here, diamond here. And what these are is if you take all of these studies, that's where they end up when you put them all together. So for overweight on that FTO gene variant, the overall effect of all these studies is right here. It is to the right of our line of effect, which means that all these studies show that there is an effect for overweight people with this gene variant. That makes sense, okay? So wherever the diamond is shows the overall effect for these studies. So you have this diamond for these studies, this diamond for these studies, that's why they're listed as subtotals, and then the overall weight, which that diamond's right there. All right, so taking together obese, overweight in that FTO gene variant, you'll see that the overall effect is to the right of the odds ratio. Therefore, there is an effect between the intervention and the treatment groups, which means there is a difference, which is good. That's what we're looking for. And so in case you don't believe me, what we can do then is if we scroll down and we go to our discussion, we can read it right, the first sentence. In this study, our meta-analysis confirmed that the variant in FTO gene, which I don't know what that is, was significantly associated with increased risk of overweight, obesity in children and adolescents. We saw it in the discussion. We come back up there. It's readily available to us in the forest plot. We have our line of effect. We have our diamonds, and we see where our confidence intervals in our whisker plots are for each individual study. Okay, so when you read a systematic review, if nothing else, when you see a forest plot, you now know how to interpret it, what to look for, and what's how many studies are on one side of the line or the other. Okay, so last couple of things, I'm going to show you another quick example. So if you look at this example of a type of forest plot, you can see the same exact thing. So we don't even know what this research study is about. But what we have here is immediately we identify our line of effect, number 1 here. This is a hazard ratio. It's the same idea behind like the odds ratio. Look for a number 1 here. Boom, we have all of our different studies with their whiskers and confidence intervals. We have the weight given by the size of the diamonds and the effects of each particular study. And there's our overall diamond sitting right there. So immediately, without even knowing what this study is about, we can already kind of start an interpretation of the data just based on the forest plot, now that you know how to sort of manipulate and walk through it. When you read this article, on the practical guide, you can see right here that they are using a 0. There are some studies, and they talk about it down here. There's your odds ratio and relative risk. Sometimes when using continuous variables, instead of looking for the number 1, you're looking for 0. And it's the same idea, the same principle. So there's our line of no effect. This time it happens to be a 0, not the number 1. Same idea though. Here's our different studies. Here's our confidence intervals. We don't want to cross that line. If we cross that line, that means there's no effect. So whether you're using a number 0 or using a number 1, the same idea applies when you're looking at a forest plot. So this is how we're going to start. And as you go through the rest of this unit, when you read your systematic reviews, your meta-analysis, they should have some type of forest plot, and now you should be able to read it, interpret it, and know what's going on there, all right? So keep this in mind, keep that practical guide handy, and continue on through the unit. Thanks, guys.